The solar system is a system made up of 8 planets, each with its own unique features, along with numerous moons and asteroids. Every planet within this system has its own surprising and fascinating characteristics. In this brand new series, we will explore each planet and dwarf planet in our solar system together, and take a closer look at what exists within it. Before we dive into the video, don't forget to subscribe to our channel, like our videos, and share your ideas in the comments for future video topics. Now, let's begin our journey through the solar system with Mercury, the closest planet to the Sun. Mercury is not only the closest planet to the Sun in our solar system, but it is also the smallest one. In terms of physical appearance, it looks very similar to our Moon. One of the most fascinating facts about Mercury is that a single day on the planet is actually longer than its year. It takes Mercury 59 Earth days to complete one full rotation on its axis, while it takes about 89 Earth days to orbit the Sun. Mercury experiences extreme temperature differences between day and night, and this is mainly due to its very thin atmosphere, which is not able to retain heat. Additionally, Mercury has no moons. The planet gets its name from the Greek god Hermes, which later became Mercurius in Latin. One of the strangest features of Mercury is its unusual rotation and orbit. As we just mentioned, a day is longer than a year on Mercury, and this results in a very unique orbital behavior. Although it completes one rotation in 59 days, a full solar day, from one sunrise to the next, actually takes about 176 Earth days due to its orbital motion around the Sun. Another oddity is Mercury's high orbital eccentricity, which is far greater than that of any other planet in the solar system. When Mercury is closest to the Sun, it's about 47 million kilometers away, but at its farthest, it can be up to 70 million kilometers away. To put this in perspective, Venus has an orbital eccentricity of 0.006, Earth's is 0.016, but Mercury's is a whopping 0.20. That's 13 times greater than Earth's. This alone shows just how unique Mercury's orbit really is. When we talk about Mercury's physical characteristics, it's roughly 1/3 the size of Earth. In terms of mass, Mercury is also much lighter. Its mass is only about 5% of Earth's mass. However, it has a surprisingly high density. Mercury's average density is 5.4 to 7 grams per cubic centimeter, making it the second most dense planet in the solar system. The most dense planet, by comparison, is our very own Earth, with a density of 5.514 grams per cubic centimeter. In terms of appearance, Mercury looks very similar to our Moon. Its surface is covered in thousands of craters, just like the Moon. These craters are often named after famous artists and legends who have passed away. The reason Mercury has so many craters is due to its extremely thin atmosphere, which is not capable of burning up incoming meteors. This allows space rocks to easily reach and impact the planet's surface. On Earth, our thick atmosphere acts like a protective shield, destroying most meteors before they hit the ground. But on Mercury, that protection simply doesn't exist. Even though Mercury's surface has large flat plains, you can unexpectedly encounter massive cliffs and steep drops that stretch for kilometers. So, when you look at Mercury's landscape, it becomes clear that the planet has an extremely complex and rugged terrain. Another interesting fact is that Mercury's axial tilt is almost zero, only about 2 degrees, which is so small that the planet is nearly perfectly upright. This makes it quite unique compared to other planets in our solar system. Earlier, we mentioned Mercury's thin atmosphere. And because of this, even though Mercury is the closest planet to the Sun, it's not the hottest planet in the solar system. The hottest planet is actually Venus, and that's due to its thick atmosphere, which traps heat through an extreme greenhouse effect. Mercury's thin atmosphere can't hold on to heat, which causes dramatic temperature differences between day and night. For example, during the day, surface temperatures can reach up to 430 degrees Celsius, 800 degrees Fahrenheit, while at night, they can drop to a freezing -190 degrees Celsius, -310 degrees Fahrenheit. Mercury's atmosphere isn't like the one we have on Earth. It's mostly made up of material blasted into the sky by solar winds and meteor impacts. That's why some scientists prefer to call it an exosphere rather than an actual atmosphere. The components of this exosphere mainly include oxygen, sodium, hydrogen, helium, and potassium. And unlike Earth's atmosphere, Mercury's has virtually no atmospheric pressure. In fact, it's almost zero. Mercury's internal structure is just as fascinating as its surface. The planet's core makes up about 85% of its total radius, with a core radius of approximately 2,074 kilometers. That's a massive portion of the planet's interior. Many people assume that, due to Mercury's thin atmosphere and small size, it wouldn't have a magnetic field. But surprisingly, it does, although it's only about 1% as strong as Earth's magnetic field. This magnetic field is believed to be generated by movements within Mercury's molten, iron-rich core. Scientists refer to this process as the dynamo effect. In the early 1900s, Newtonian mechanics could accurately explain the motion of most planets in the solar system. However, when it came to Mercury, something didn't add up. Mercury's orbital behavior didn't follow the predictions made by Newton's laws. At the time, some scientists suggested that there might be a hidden planet near the Sun, one that couldn't be observed from Earth. They believed this mysterious planet's gravitational influence was disturbing Mercury's orbit, which explained why it didn't quite fit Newton's model. But then came Albert Einstein. His theory of general relativity offered the perfect explanation. According to this theory, planetary motion isn't solely governed by gravity in the classical sense, but rather by the curvature of spacetime caused by massive objects like the Sun. When viewed through the lens of general relativity, Mercury's unusual motion made perfect sense. In fact, this theory not only explained Mercury's orbit precisely, but also brought a revolutionary understanding of gravity and the universe itself. Mercury is actually not one of the most popular or talked about planets in our solar system. Because of this, there aren't many theories or sci-fi fantasies centered around it. However, its physical characteristics and the fact that Newtonian mechanics couldn't fully explain its motion made Mercury far more intriguing, especially after Einstein's theory of general relativity came along and provided a perfect explanation that could be observationally confirmed. Unlike planets such as Mars, which constantly make headlines due to their Earth-like features and potential for future exploration, Mercury tends to stay under the radar. Unfortunately, the amount of scientifically confirmed information we have about Mercury is still quite limited. We hope that one day, all planets will receive the same level of scientific attention and curiosity. That's all from us for today. If you'd like to support the growth of our channel, don't forget to subscribe, like the video so it reaches more people, and leave a comment with your thoughts or suggestions for future videos. Take care of yourselves, and we'll see you in the next one. Thanks for watching.